Find the discriminant of each equation and describe the nature of the roots of the equation. Then solve each equation by using the quadratic formula and graph the related function. Let's just do one thing at a time. Let's find the discriminant. The discriminant is b squared minus 4ac. b in this case is 19. A in this case is 4, and C is negative 5. Put that whole thing in your calculator, which I'm permitting you to. You get the discriminant is 441, not 444. 441. So part 1 is done. What's the discriminant? It's 441. Part 2, describe the nature of the roots of the equation. Well, since this is a positive discriminant, the nature is there's two different real roots. So we're going to get two answers for this, and they're going to be real numbers. That's what that means. Then solve each equation. So to solve this, it says solve using the quadratic formula. X is going to be equal to negative b plus or minus the square root of the discriminant over 2a. So we have a negative b is 19, plus or minus the square root of 441, divided by 2 times a is 4. Simplifying this just a nubbin, we get negative 19 plus or minus 441 is a perfect square, square root's 21, over 8. This gives us negative 40 over 8, comma, and 2 over 8, which reduces to a negative 5 and a 1/4. So we have here our x-intercepts, negative 5 and positive 1/4. And we're supposed to graph the related function. Well, to do that, we need to find the y-intercepts, the y-intercept singular. To do so, we take the related function, replace the x values with 0, and we get a y-intercept of negative 5. X-intercepts, y-intercept. Looking at this related function, y equals 4x squared plus 19x minus 5. Just by looking at it, we don't know where the vertex is. We know it's a parabola because it's x squared. We know that it opens up, has a minimum because the leading coefficient is positive. We don't know where that vertex is. So the easiest way to find it, by the way we did this problem, is to find the derivative, which would be 8x plus 19, set it equal to 0, solve that. It's going to give you a critical value of negative 19 over 8. To find the critical point, we take that critical value and plug it into the original function. It's going to give us negative 441 over 16. Once again, by looking at the original, we can see this is a parabola that's concave up, so we know it has a minimum. So from this, we can say we have a ordered pair, negative 19, 8, negative 441, 16, and it's a minimum. So now we just have to graph it. Putting all this together, our minimum is in quadrant 3. We know it opens up. So we got negative 19 over 8, comma, negative 441 over 16. is our minimum. We found a y-intercept of -5. We found x-intercepts of 1/4 and another x-intercept of -5. So we're supposed to graph it. We did it. Find the discriminant of each equation. Let's do that first. The discriminant is b squared minus 4ac. So in this case, that's a 3 squared minus 4 times 2 times 3. Putting that in your calculator, you're going to get -15 as the discriminant. Describe the nature of the roots of the equation. When you find the discriminant, that tells you the nature. If it's a negative answer, which this is, it means there are no real roots. Since we're trying to find x-intercepts for this, there are no real x-intercepts. X-intercepts, there are none, so when we graph it, it's not going to cross the x-axis. Solve the equation by using the quadratic formula. There's no sense in doing that since we're going to get no real numbers. Graph the related function. To do that, we need to find the y-intercept. Take the related function. To get the related function, take the 0 that it's equal to and replace it with y. To find the y-intercept, replace all the x's with 0. We get a y-intercept of 3. So it crosses the y-axis at 3, no x-intercepts. We know it's a parabola because it's a quadratic, and we know it opens up because the Lie coefficient is positive. To figure out what that minimum is, we're going to have to find the critical point. To do so, we find the derivative, set it equal to 0, and solve that little tiny baby equation to get a critical value of x equals -3/4. Critical value is the x value of our minimum. To find the y value, we take this -3/4 and put it back into the related equation. Feel free to use your calculator to save us some time here, although you should be able to do it without a calculator, if I would ever ask you to do so. So we have a minimum at -3/4, 15/8. So now what's left to do is to graph this. Putting all this information together, our minimum is in quadrant 2. It opens up. There's no x-intercepts because it doesn't cross the x-axis. Has a y-intercept of 3. So there's your graph. Find the discriminant of each equation. So let's do that. Discriminant is b squared minus 4ac. B in this problem is -39. A is 6. C is 45. Go ahead and put this whole thing into your calculator. You're going to get the discriminant is 441. Dark on it. Second part of the instructions. Describe the nature of the roots of the equation. Well, since the discriminant is positive, this is going to have two distinct real roots. That means two different x-intercepts that are real numbers. To find the x-intercepts, then, we continue with the quadratic formula, which is -b plus or minus the discriminant, the square root of the discriminant, divided by 2a. So we have a negative b. B is -39. Discriminant is 441. Divided by 2 times a is 6. Negative negative 39? Well, that's a positive 39, children. Square root of 441 is a perfect square root. It's 21. 2 times 6 is 12. This ends up giving us 18 twelfths and 60 twelfths, which reduces to 3 halves and 5. Our x-intercepts are 3 halves and 5. Solve each equation by using the quadratic formula. That's what we just did. So solving it gives us the x-intercepts. Graph the related function. To graph the related function, we need the y-intercept. Take your related function, replace the x values with 0 to find the y-intercept. We get a y-intercept of 45. This parabola, yet again, opens up because the Lie coefficient is positive. So to figure out what that minimum is, to find that minimum, we take the derivative, which is going to be 12x minus 39, set it equal to 0, and solve it. You end up with a critical value at x equals 39 twelfths. To make that a critical point, you take that critical value and put it into the related function. It ends up giving you negative 147 over 8. Feel free to use your calculator just to save yourself some time, although you should be able to do it without a calculator if I ask you to do so. So, we have our x-intercepts, our y-intercept, and our minimum for our parabola. Y-intercept is at 45, and the way I just drew this is not great. Pretend like that's not there. How could you possibly pretend like that's not there when it's so big and obviously there? So we have a y-intercept of 45. Oh, I have to write super tiny to fit in the space. Such a noob. We have x-intercepts of 5 and 3 halves. And there's a minimum down here, which I'm never going to be able to fit it in. So let me just write min here, and then I'll write the coordinates over yonder. 39 twelfths, comma, negative 147.8 divided by 8. There's your graph. Sorry about this hot mess that I told you to ignore, and yet you can't because it's so big and because I'm pointing it out, literally with arrows.